So good afternoon, everyone. Today I'm going to present on the topic determining soil acidity neutralization capacity of crushed basalt. So this is a small experiment that part of my PhD work, and it consists of three objectives. First, to characterize the mineralogy and elemental composition of basalts, focusing on the potential for alkalinity protection and base cation release. And second, to evaluate the effectiveness of basalt in reducing the soil acidity through soil incubation experiment. And third, to determine the acid neutralization capacity of basalt using the laboratory titration experiment. For the objective one, I have choose three different type of basalt from Australia. So these three basalts have been used in the enhanced rock weathering field trials in Australia. So the first basalt is from the Kangaroo Island, South Australia. And this basalt used in the Kangaroo Island field trial for the grain. And the second one, Wagner's Shefton Quarry basalt, used in the Central Queensland Smart Cropping Centre field trial. And War Crusher Dust basalt used in the Sunrise trial in New South Wales. For the characterization of basalt, for the grain size less than 4 mm, I used the mass fraction sieving. For the size less than 75 micron, I used the ecosizer using the laser diffraction method. And coming to the geometric specific surface area, I used the Mastersizer 2000 and mineral phases by XRD, elemental composition using SEM EDS, and the total HF digestion, like the total elemental digestion, is being analyzed using the HF digestion method followed by the ICP-MS, so the analysis is in progress. Coming to the results of the particle size of basalt. So the first Kangaroo Island basalts shows a P80 value of 1709 micron, and with a geometric specific surface area of 1.792 square meter per gram. And that shows the highest P80 value and correspondingly the specific surface area. And then comes the Wagner's Shefton Quarry. It comes around 1501 micron. And next comes the War Crusher Dust. So it's lowest for the War Crusher Dust that is in the New South Wales sample. In case of mineralogy and of basalt, as per the XRD and the SEM EDS, in the left side, you can see the XRD data that I have plotted in the pie chart. In the right side, it's the SEM EDS mineral mapping data. So for the Kangaroo Island basalt, it mainly consists of diopside, and then comes the augite. So from this, diopside and augite comes in the plagioclase feldspar group. So it is, pyroxene group. So this is mainly dominated by pyroxene feldspar, then the plagioclase. And in the right side, you can see the SEM EDS data in which the lighter portions for the pyroxene family and the darker portions, it's for the plagioclase and analyzed using the mapping. Coming to the Wagner's Shefton Quarry basalt in Queensland, you can see almost it is highly rich in anorthite that comes under the plagioclase feldspar, and then only the pyroxene group of family comes. In case of the War Crusher Dust basalt in New South Wales, it is highly rich in analcime. So in the last, like the Kangaroo Island basalt and the Wagner's Shefton Quarry, it's very clear that it is highly rich in pyroxene or plagioclase. But here, coming to the New South Wales sample, it is highly rich in analcime. So analcime comes under its zeolite group of family, and it's a secondary altered one. And from here on the slides, I'll be addressing the Kangaroo Island, all the basalt in name of the place from its I used like in South Australia, Queensland, and New South Wales. For the objective 2 soil incubation experiment, I used two different type of acidic soils. So first one from the Malala soil. So it both the soils from the South Australia. So the Malala soil, it is a sandy loam soil, and Umali soil, it is sandy soil. And how I did the incubation is, I sieved the soil less than 2 mm and dried the soil, and 300 gram of soil, it's being incubated in 500 ml containers. So I used 5 different treatments, in which 3 treatments is for the basalt with different grain size, less than 75 micron, 75 to 250 micron, and 250 to 4000 micron. And apart from these 3 treatments, agricultural lime, laboratory lime, like the calcium carbonate, the pure, and the control, it's being used as a standard. And the basalt application rate I used in this incubation is 40 ton per hectare. And the incubation is for overall 6 months and maintained with a water holding capacity of 70%. Coming to the characterization of the basalt, I characterize that the pH, easy, alkalinity using the autotitrator, total organic and inorganic carbon using the CN analyzer, and water holding capacity, pH buffering capacity, and CEC. So the CEC, it is being used by ammonium chloride extraction method, followed by the ICP-MS. So among this characterization of soil, the pH, EC, alkalinity, and CEC, I'm analyzing every month. And the rest of the pH buffering capacity and total organic and inorganic capacity I analyzed for the baseline soil, and I'll be analyzing after 6 months of my incubation. Coming to the results of Malala soil pH, so I completed only 4 months of incubation at this moment. So here you can see for the grain size less than 75 micron, the pH raise is quite high, and the samples basalt from the Queensland and New South Wales shows a higher range of pH while comparing with the Kangaroo Island basalt, the basalt from the southern Australia. And the variation is high for less than 75 micron and 75 to 50. And it is expected that the pH rise will be quite low with the higher fraction of basalt. Coming to the alkalinity, in the first 3 months, it was almost decreasing. And finally, in the 4th month, it suddenly increased the alkalinity. And it is quite high for the less than 75 micron. In case of Umali soil pH, for the first 4 months, as same as it happened for the Malala soil, the Queensland and New South Wales soil shows higher pH raise. And in the 4th month, you can see it's coming to a stable or steady state for the pH. And for the size of 250 to 4,000 micron, it shows very less reaction while comparing with the smallest fractions. And apart from the Malala soil, in the Malala soil, we can see a rise in the alkalinity in the 4th month. But while coming to the Umali soil, there is a decline in the alkalinity. And when I check the baseline soil analysis of both of this, the carbon content, it is quite high for the Malala soil, and the C-cation exchange capacity is also high while comparing with the Umali. And for the objective 3, for the titration experiment, so I took around 0.4 gram of basalt, and the fraction I used here is less than 75 micron. So 0.4 gram of basalt was added to 20 ml of 0.5 normal HCl. Then the mixture is shaken in the shaker I covered this with a parafilm, and it's shaken for total 48 hours in a temperature control room. Then I added phenolphthalein and finally back titrated using NaOH with the same concentration, that is 0.5. And I did this titration for all the 3 basalts from South Australia, Queensland, and New South Wales. And at this meanwhile, I titrated, standardized this HCl and NaOH using the sodium carbonate and potassium hydrogen thalite. So coming to the results of titration experiment, the acid neutralisation capacity, it's highest for the Queensland sample, then comes the New South Wales one, and then comes the South Australia. So as the incubation and titration, it's almost quite different setup, but still we can get, the Queensland sample shows highest acid neutralisation capacity, and it's coming like a plateau at around 48 hours. In case of my future directions, I want to continue this experiment for total 6 months, and I want to evaluate. Right now in my experiment, I used at different particle fraction, but I want to use less than 4 mm without any fraction as we are getting from the industry. So that's what one of the future directions I want to do, and conduct the titration experiment in aspect of the ISO certified protocol. And at this moment, I did it for 48 hours of titration, and I was thinking to do it for 72 hours or to increase the time, and to complete the elemental analysis of HF digested samples, and to determining the pH buffering capacity of both the soils to analyze more about the variations happening, and to conduct the organic and inorganic carbon analysis and CEC after 6 months of my incubation. And I acknowledge my principal supervisor, Binoy, and co-supervisors Enzo, KZ, Ure, and Paul. So thank you.